way to Dallas, though. That's a thing. Day6. Wearing the shirt right now. That's cool. Yeah. I'm way tired though the next day. I'm dead. My voice is gone.
How y'all doing?
Tired.
I'm tired too. All right, so we're going to move on today and start linear equations. In two variables. All right. So as a reminder, we've already looked at linear equations in one variable. Turn this on. So recall, if we have a linear equation in one variable, then an example of that would be something like this. 3x minus 4 equals, let's say, x plus 2. We've looked at those already, right? We have an equation. There's one variable, and it is linear because the power on the x is 1, right? So we've looked at this. And whenever we worked on things like this, we always solved these. So we will always have a solution to this. Something like, well, in this case, we'd move all the x's to one side, so 2x, 6. I think you get x is 3 here. Okay, so you get one answer. That's not what we're doing today, all right? So what we're going to do today is look at linear equations. So same thing, linear equations, but this time two variables. So let me give you a very simple example of this. X plus y equals 10. So now you have an equation, you have two variables. We're still linear because both the variables, x and y, are both to the first power, right? So does anyone know where we're going with this? Like what a linear equation in two variables is going to lead us to? It's okay if you don't. No? Okay, then can somebody give me an x and give me a y that would make that true? 5 and 5, right? So if I let x be 5 and I let y be 5, then this is true, right? Okay. That's not the only answer. 6 and 4. Okay, if I let x be 6 and y be 4, that would work. I heard 8 and 2. Right? How about 0? 0 and 10 would work. So how many solutions are there? How many x's and y, how many pairs can I come up with that would satisfy that equation? How many different ones could I come up with? You think you could just keep going for the rest of your life? Do you think you could keep coming up with examples? You could. I mean, just keep, let's do a negative number. How about negative 4? If x is negative 4, then what would y have to be? Positive 14, right? So if you add these up, you're going to get 10. So there's an infinite number of pairs, right, that we could get that would make this true. Over here, there's one answer only. X is 3, that's it. That's the only answer that works, right? So here we have an infinite number of what we're going to call ordered pairs. Okay, ordered pairs. An infinite number of ordered pairs as solutions. All right, so I said pairs, right? 5, 5, 6, 4, 8, 2. Those are pairs of numbers. The word ordered here means that the order of the pairs matters, right? Like, well, in this example, I can switch them, can't I? Can I? Just flip them and they still work? But they're different because if I let's say, x be 3, right? then y is 7, is not the same as 7, 3. This pair, you're letting x be 7, y be, x be 3, y be 7. And then this one, you switch them, right? So even though these both work, these are distinct answers, all right? So whenever we're talking about pairs, we want to take into account the order in which we're putting. Like which one is the x, which one is the y. And in general, what we do to write these ordered pairs, and I'm sure you've seen this before, is we put a set of parentheses, a comma, then we put the x here and the y here. All right? So in this particular example here, the ordered pair would be 5, 5. This one would be 6, 4. This one would be 8, 2. Right? And so on and so forth. Now that I've done this, do you know where we're headed? What are we going to do with this? What's that? We're going to graph it. Okay, so here we have one answer, right? We have one answer only. Over there we have an infinite number of answers. So what we do is we try and see if there's a way that we can visualize all of those answers. They all have something in common. When we look at them, they have something in common. So I guess our direction now is to try and somehow visually represent these answers. All right? So what we do is we go and we draw our x and y axes. X and y, and then what we do is we start plotting these pairs on our axes. So if I do the pair 5, 5, that means I'm going to go to the right 5. That's my x, right? And then my y, I'm going to go 1, 2, 3, 4, 5. So 5 over, 5 up, and I put a dot. That dot represents that answer visually, right? And then I do the next one, 6, 4. So I go to the right 6, this time up 4, and I'll be about right here. And then I can continue. Let's see, 8, 2. So to the right 8, 7, 8, there's 8, and up 2, right there. And then I could keep doing this all day long, right? Actually, I could do that for the rest of my life. I'd die before I finish, right? Because there's an infinite number of answers here. But they all have something in common, and what is that? They all lie on a straight line, okay? And only linear equations in two variables have this property, that all the answers will live on a straight line. So if I were to continue filling in dots, right? Dot, 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 all those answers, dot, 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 then what I get is a solid line. Everything on that line, every point on that line is a solution to that linear equation in two variables. So there's like fractions in there also. You could have, you could let x be a half, and then you could figure out what y is, right? So in that case, it would be like 9.5. So what's that? 9.5. 9.5 plus a half would give you 10. So written as the other way, 18, 19 halves, right? Add those two together and you get 20 over 2, which is 10. So I could plot this, 1 half, go up 19 halves, and here's what I can tell you, it's going to lie on that line, all right? So all a line is a visual representation of the solutions to a linear equation in two variables. Got it? All right, so what happens if I change this equation and I make that like squared instead? Do we have a linear equation in two variables now? We do not. Now, do we have solutions? Yes, we do. But when you plot them, they are not going to live on a straight line anymore. That's going to be a parabola, and we'll study those later, all right? So it's very important that we have it raised to the first power. Where did my little thing go? Oh, it's right here. Okay. Used to the yellow one. All right. So our goal today is for me to be able to give you a linear equation in two variables, and you be able to plot the solutions, all right? To draw the line. So in a summary here, the solutions to that, a linear equation, two variables, is a line. Now, going back to what you know about lines, how many points do you need to draw a straight line? 2, right? That's the minimum that you need. If you have 2 points on a line, you can draw a line through them, right? So all we will ever need to draw the solution, or draw the line, is 2 points, or 2 ordered pairs okay, 2 ordered pairs. That's it. If we can just get 2 points, if you want, you can think of that as points instead. If we can get 2 points, then we're in business. Yes? Okay, so let's look at our first example. And let's go back to the one we just did. I know that we've already done it, but I want to show you how we're going to approach this systematically. Okay, we're given a linear equation and 2 variables, and now we want to sketch it. We want to sketch the line that represents all the answers. So we are going to use right now what's called the intercept method. And there are going to be 2 methods we use. All right, this is the first of the 2. And on a test, I don't care which method you use, whichever one you want, but you should be equally comfortable with both. So the way that the intercept method works is this. The idea is that if I draw a line, right? Let's say I have, my XY axes here. If I draw a line, as long as the line is not vertical, straight up and down, and as long as it's not horizontal, straight left and right, then it's going to have some sort of tilt to it, right? And if it has any sort of tilt at all, then it's going to have to hit both the x-axis and the y-axis somewhere, right? As long as it's tilted a little bit, right? Do y'all see if it's straight up and down, it would hit the x but not the y? Or if it's flat like this, it would hit the y but not the x. Okay, so as long as there's some sort of tilt, then I have to hit the y and the x somewhere. These are called, well, this one is called the x-intercept. And of course, this one is called the y-intercept. So do you agree that if we could find those 2 points, that's all we'd ever need? We just draw a straight line through them? Okay? So that's what we're going to do. This intercept method is going to have us go out and try and find these 2 points. So let's do it for this one. And here's the standard procedure. Let me do it over here. The standard procedure for the intercept method is as follows. To find the x-intercept, does anyone know how you find the x-intercept? I'm going to do x-int for x-intercept, right? How do we find the x-intercept? So think about this. Think about this point right here. That's the x-intercept, right? Can you tell me right now, just by looking at this, not what the x is, but can you tell me what the y has to be? 0, right? Because if you're on the x-axis, your y is 0, right? Agreed? So y is 0, you don't know what that is. How about over here? What can you tell me about that point? The x is 0 and the y you don't know, right? So if you want to find the x-intercept, you know that y has to be 0, right? So to find the x-intercept, what we do is we set y equal to 0, and then we solve for x. All right? So let's take our original equation right here. We're going to take x plus y equals 10. We're going to set y equal to 0. So I'm going to replace this with 0, right? And x plus 0 is still x, so x is what? 10. Okay, so I know what the x-intercept is now. I'm going to write it as an ordered pair. It's 10, and then what's the y-coordinate? 0, because that's how we got it, right? So I know 1 point now. I just need 1 more. If I get 1 more, I can draw a straight line, I'm done. So now I find the y-intercept. And how do you find the y-intercept? Set x equal to 0. So it's the opposite of what you're looking for, right? If you're trying to find the y, you set x to 0. And here we'll solve for y. If you're trying to find the x-intercept, you set y to 0, solve for x. Okay, so we use the same equation. And replace x with 0. You get y is 10, and then we write our ordered pair. What's our ordered pair? 0, 10. Boom. We have our second point. As soon as you have 2 points, you can draw a straight line, and you're done. So the final part of this is to draw the picture. All right, so let's draw a picture here now. So my x-intercept is 10, 0, so I go out to the right 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put a dot. My y-intercept is 0, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Draw a dot, 10, and then connect those with a pretty straight line. Make it a little bigger. There we go. Right? So this problem was relatively easy, right? There was nothing crazy about the equation. Everything worked out nice. The important thing is just the method, okay? So now we try something. We try a slightly harder linear equation in 2 variables and see if we can do the same thing, all right? Any questions on the method? Okay, let's do a harder one. Okay, let's do this one. Let's sketch this line, 3x, bless you, plus 2 times y plus 4 equals 7. All right, so is that a linear equation in 2 variables? You see an equal sign? So it's an equation. Do you see 2 variables? Okay, are they linear? First power, so yes, that's what we have. So with this method, the intercept method, all I have to do is find the 2 intercepts and I'm done, right? You might be sitting there right now saying, oh, we could distribute the 2, right? We can, but we don't need to, because the intercept method just says, go find the intercepts. So let's not waste any time. Let's just go right to it. So I'm doing the intercept method. All right, let's find the x-intercept. To do that, let's set what to 0? Y. Okay, so I'm going to rewrite the equation. 3x plus 2y is going to be replaced with 0 plus 4 and equals 7. Right? All I did was replace y with 0. And now, when you look at this, and I didn't mention this in the last problem, but when you look at this, don't we now have a linear equation in 1 variable? Right? And so we should have a unique solution, and that's going to be our intercept, right? So we've somehow transformed a linear equation 2 variables to 1. All right, so now let's do this. All right, it's wake up time. So let's get my little sticks over here. Uh-oh. Can y'all believe it's almost October? Okay, Evan. How's it going, Evan? All right, so Evan, what happens here? So can you give me the next line, something different than what's up here? So 3x stays, plus 2, and this is times, right? Yeah. So what would this be, this all together? Plus 8. Right? Plus 8. So 2 times 4 equals 7. Okay. You want to keep going, Evan? Sure. Okay, so we're now trying to solve a linear equation in 1 variable, try and isolate that x. So what would you do next, Evan?
Take away 8.
Take away 8. Okay, subtract 8, subtract 8. Everyone good with that? Okay, so 3x equals -1. Last step, divide by 3. Okay, so if you divide by 3, you get -1/3. So this is going to kind of suck, right, Evan? Because we have a fraction as our x-intercept. And you know what? That's life, okay? And sometimes you have to work with fractions. So there it is. All right, so now we move on. We're going to go get the y-intercept. Right, Josh?
Yep.
Okay, there you are, Josh. All right, so how do we find the y-intercept, Josh? Bless you. Yes, I'm going to say yes and no. So yes, we are going to solve for x, but or not solve for x. We're going to solve for y because we're trying to find the y-intercept. But what do we have to replace something? x is 0. Okay, so we're going to rewrite the equation, the original one, with x being 0, so 3 times 0 plus 2 times y plus 4 equals 7. So in this one, Josh, this goes away, right? So now you need to go solve for y. So how would you solve for y here? Got that parentheses. You don't like that, right? Distribute. Okay, so distribute the 2 through. We get 2y plus 8 equals 7. And then now we're kind of like where we were here. We're just going to try and get that x by itself, right? So next step, subtract 8. We can get a negative 1 again, aren't we? Just a coincidence, okay? All right, and finally, divide by 2, and we're there. Now, I forgot to write this as an ordered pair over here. This is an ordered pair, isn't it? It's the ordered pair negative 1/3, 0. And then over here, it's the ordered pair 0, negative 1/2. That's it. We have 2 points, don't we? Put those points, plot them, we're done. The thing is, how do you plot the fractions, right? So we are going to try it. We'll do our best. If you want, you could use your calculator to get a decimal, if that helps. Negative 1/3, right, on the x-axis. So the way I'm going to do this is I'm going to say if this was negative 1, right, negative 1/3 would be about 1/3 of the way that direction, right? So about 1/3 this way. So I'm just going to eyeball it. This is negative 1/3. I'm going to put a dot here. Okay, and then negative 1/2 on the y. So if, let's say, again, this is negative 1 here. Negative 1/2 would be about right there. Bless you. Right there, like that. And then once you have that, you draw your line. Okay, straight line through here. And we're done. Questions? All right, let's do another one. Linear equation, 2 variables, right? All right, so let's start this off. Let's see here. Trying to wake you all up. Christian? All right, Christian.
In order to solve this, I think I'd go with solving for the y-intercept first.
You want to do the y-intercept first? Any reason why? Just
I usually
that's what you want to do? Okay, that's fine. So you want to go after the y-intercept first? That's perfectly fine. If you're going to do that, you're going to replace what with what and solve?
just x with 0.
X with 0, so that's going to go to 0. That's going to go away. And then minus 3y equals 12, like that. Okay? So what's my next line, Christian?
Next time would be it'll just be negative 3y
Uh-huh.
equals 12.
Okay, and then last? You solve them for y, right?
So it would be y equals 4.
Close? You're dividing both sides by negative 3, right? So you're going to get net positive divided by negative, so you should get negative 4. Now you got the y-intercept first, so this is the ordered pair 0, negative 4, right? All right, let's see here. Lisa. Hi. So Christian got the y-intercept first, which means that you're left with the x-intercept. Okay, so to find the x-intercept, you're going to do what?
Put the y to 0.
Turn the y into a 0. So I'm rewrite the original equation. 4/3 x minus 3 times 0 equals 12. And this right here, Lisa's going to just go away, right? So all you're left with is 4/3 x equals 12. And now you have to deal with that fraction. So how do you want to do that? I mean, there's multiple ways to do this, so I'm just curious how you would want to do this. Okay, so let me ask you this. If that was just a 4, what would you do?
Take the 4 away from 4x and the 12, or divide the 4.
Divide. You would divide, right? But it's 4/3, right? So because it's 4/3, we can still divide this side by 4/3 to make it go away, but then we have to divide that side by 4/3. So let's do that, all right? Let's do 4/3 over here, and then we're going to take this and divide by 4/3, right? And it's going to go away. Okay, so the question is, on the right side, 12 divided by 4/3, how do we get that? Well, let's write it this way. 12 divided by 4/3, right? That's what it is. And then to do division, 12 over 1. Okay, so you're going to rewrite 12 as 12 over 1. And then to do division, flip it, make it multiplication. 3 over 4, like that. Straight across. So this is going to be 36 on top and 4 on the bottom. 36 divided by 4 is 9. So x is 9. And that means that our x-intercept is 9, 0. And these should be relatively easy to draw on a number line, right? These two. So I'll do a quick one over here. Let's see. Let's be careful. 9, 0 is 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9, 0. And then 0, negative 4, 1, 2, 3, 4. You know what? Let me do something different. 1, 2, 3, 4, negative 4. So am I allowed to do this? See how from left to right, I said this was 1, 2, 3, 4. So I'm like, they're really, really close together, aren't they? But then on my up and down, that's negative 1, negative 2, negative 3, negative 4. So like 1 unit this way and 1 unit this way are not the same. Am I allowed to do that? Yes. Okay. We call this changing the scale. So the scale this way, whatever you want it to be, you can let it be that. This scale can be something different. And I'll show you in the next example why this would be important. All right. I just wanted to illustrate that you can. What you cannot do, okay, you can't do this. You can't be like, okay, this is 1, 2, and then 3, and then 4. You can't do that. 1, 2, 3, 4. Like that doesn't make sense. Like 1 unit, you got to be consistent left and right. You just don't have to be consistent left and right versus up and down. So I could draw my line and be done. Okay? So intercept method is pretty okay. I mean, no craziness to it, you think? All right, so let's do an example where I can illustrate that again a little bit more. How about this? How about 30x minus 2y equals let's just go with 30. And I'll just keep it that way. So x-intercept, I'm going to just go through this one quickly. X-intercept, replace y with 0. 30x equals 30, because that goes away. Divide by 30, you get x is 1. Right? Okay, on the next one, y-intercept, I set the x to 0. So that's gone. So I have negative 2y equals 30. So y is negative 15. So I have 2 points, 1, 0, and 0, negative 15. Y'all follow that? If I go to graph this, right, 1, 0, if I do that, like if I say, okay, this is 1, this is 2, 1, 0 is here. Now, do you see what I'm going to run into here as a problem if I continue with this graph? 0, negative 15. If I use 1 like this, then I'm going to be way down here, right? Which I may not have enough space for. Or what if this was negative 150, right? Then I'd have to go way down there. So I'm just going to change the scale. I'm going to say, like, let's just say that this is 5. So this would be negative 5, negative 10, negative 15. Right? And then I put my point here. And that way it all fits. All right? You're allowed to do that. I think we're ready for a word problem. Robert is a used car salesperson. Oops. Okay, I sell used cars on the side, all right? And he makes, let's say, $500 per week plus 3% of his sales. So I'm working on what's called commission. I go into work and I stand there and I wait for people to pull up to the car lot, right? And as soon as they get out of the car, I run up to them and, right, bother them. And so if I just show up, I'm going to make $500 a week. That's it. But if I sell a car, I'm going to make 3% of the sale price of the car. All right, so what I want to do here is I want us to find a linear model for Robert's weekly pay in terms of his sales. All right, so this problem right here is exactly one of these problems, all right? It's just now it's worded like more real world situation. But it's the same thing. We want to find some linear model, draw the line, all right? So can we try and come up with some idea of what my sales are going to be, or sorry, my pay. I want to know what my weekly pay is. So let's call it P, all right, for pay. My pay is going to be what every week? 500 to start, right? 500? No matter what, 500. Plus, I'm going to make how much? 3% of my sales. How do I write that? 0.03, because you have to convert it to a decimal. 0.03 what? X would be, okay, X would be if we want to say X is, what is X? My sales, right? We could do S too, right? We did P, we may as well do S. So let's call this right here. So just to be clear, P is going to be my weekly pay. And my S is going to be weekly sales. Okay? So this is a model of how much I make, right? If I sell nothing, S is 0, right? Then I make 500. But what if I sell $30,000 worth of cars, right? So what we're going to do is we're going to draw a model, right? Because isn't this a linear equation with two variables? Okay, so we should be able to draw a line. So let's do that. So what am I going to find first? Hold on, let me pull someone's stick here. Frank? Right? So this is a linear equation in two variables, right? So the way we've been doing this, we've been finding the intercepts. So which intercept do you want to find first? The x, right? So, but is there an x in here? There's no x, so we better call it something else. The p-intercept. Does that make sense? Okay, we can find the p-intercept. We can also find the s-intercept. Correct? Okay, so you want to find the p-intercept first? To find the p-intercept, we set s to 0, right? Set s to 0. Okay, so if I do that, p equals 500 plus 0.03, s is 0, sorry. And that just goes away, and all you get is 500, right? Okay. And then the next one is the s-intercept. And to do that, you set p to 0, yes? Okay, so if I set p to 0 in this equation, I get 0 equals 500 plus 0.03s. And who's going to get the pleasure of solving that? Vince. Okay, you with me over there?
Yeah.
Sure? Okay, so you get to solve for s now. So how would you solve this for s?
Move 500 to the other
Move 500 to the other side, so negative 500 equals 0.03s, and then what would you do there? Divide both sides by 0.03. And maybe we need our calculator now, right? So let's get on our calculators and do 500 divided by 0.03. Oh, negative 500, sorry, divided by 0.03. Get, let me see, 16, negative 16, 666.666 equals S. Are y'all getting that? Something seems wrong, but yeah, that's okay. Y'all okay? Okay. So now let's try and plot this. Let's draw the line. I have a p-intercept and I have an s-intercept. And I'm about to ask a question. I'm not sure how this is going to go, but let's see. Elena? Okay. Which is P and which is S? Because you know how we had X and Y, we just have always been doing X and Y because that's what we've always just been taught, right? So which one is P and which one is S? You want P to be this way and you want your S to be that way. So can we do it that way? Yes, it's totally up to us. We can make this P and this S. Now, I want us to consider it the other way, and let's just see which one of these, even though they're both okay, which one of these seems more reasonable or seems to make a little more sense. This one, this is going to be your sales, right? And this is going to be your pay. Here, this is going to be your pay, and this is going to be your sales. Which of those two seems like you would rather see? Do you want to stick with this, or do you think this one, would you rather see this? Like where it shows, okay, if I sell this much, here's how much I make. This one makes a little more sense, right? So even though you could do it both ways, this one I think is the one that makes more sense. We're going to have sales this way, pay this way. Okay, so let's stick with that one. See, there's nothing that tells you have to do one or the other. You have to make that decision. So sales here and pay here. All right, so let's get our p-intercept. Our p-intercept is where our line hits the p-axis, right? And where does it hit? At 500. Okay, so where do we put 500 here?
200.
Yeah, you want to just do a couple of hundreds here? How about 100, 200, 300, 400, 500? There's 500. And I put a dot there. Okay, great. Now, where's my s-intercept? Negative 16,666.66, which is way out there, right? Way out there? Okay, so I should probably count this way by, I don't know, thousands or maybe 5,000s or 10,000s. Let's do 10,000s. Let's say that's 10,000. Then this would be, oh, sorry, negative 10,000. Then this would be negative 20,000, right? That right there would be what? Negative 15,000 about? And we need to go to negative 16,000, which would be, I don't know, we're just going to eyeball it right there. We're going to say that that's negative 16,666, whatever, 0.66. So then we draw a straight line, connecting those like that. Y'all with me? Okay. Devin, what is wrong with this? There's something wrong right now. I mean, it's right, but there's something wrong with that drawing. Think about the word problem, okay? This word problem, this graph should represent our pay in terms of our sales, right? So does this whole graph make sense? Yeah, like this doesn't make sense over here, right? Because over here, you would be implying that you have negative sales. No, we don't have to convert it. We just only want to look at this graph this way. So our graph, the thing that we're interested in, starts here. Ooh. Starts here and goes that way like that, right? The blue graph is the graph that represents our pay. This part over here was just so we could draw the line. But this doesn't make sense in terms of our sales. I mean, right? You're not going in and working and selling a negative amount unless you're taking the car out for a test drive and crashing it, I guess. Then you're losing money. I'll never forget, I was test driving a car in Dallas once. And I'm not used to Dallas traffic. And I almost wrecked it on the highway. It was so bad. The dealer guy that was in the car with us, the look on his face of fear, it was because he was in my rearview mirror. You're sitting in the middle. Whew. Got lucky. Okay. All right. So do you see here, word problem, linear equation, two variables, we have this picture. So this is a visual representation where if our sales goes up, then we get, right, a certain amount of pay. So I'm going to add one more question to this. So adding on to this, what sales are required to make $1,500 in a week? Zeke. All right, same problem, same salesman, same everything. So what is this problem now asking you? Or how do you think we should go about figuring this out?
Another equation.
Okay, what equation? What is it asking for us? What is it asking? What?
What's
Sales, right? It wants to know what our sales need to be in order for our what to be 1,500. This 1,500 is our what? Is that our sales? That's our pay, right? So this is our pay, right? So this is saying, look, where, this is our pay, right? Saying where on this line, somewhere over here, right? There's a point there where our pay is 1,500. Right? That's our pay. And it wants to know what our sales need to be. Does that make sense? Does it make sense?
Yeah.
Okay. Now remember, we had an equation, didn't we? What was our equation? We came up with this on our own. It was P equals 500 plus 0.03S, right? That's the thing we were working on. That's what we graphed. This question is saying, hey, look, if P is 1,500, go find sales, right? So use that equation right there. Replace what with what? What am I going to replace here? Replace which letter with 1,500? The P, right? So we're going to replace P with 1,500. If we do that, then the only thing left is sales, or S. So now this question translates into 1,500 equals 500 plus 0.03S. And now we solve for S. So I'm curious to see how much sales we would have to have here. Let's see, we subtract 500 on both sides first. And divide 1,000 by 0.03, right? So our sales would need to be 33,333.33 sales. So this is dollars, isn't it? Okay, so about, let's just round, about $33,333. If we want to make $1,500 in a month, then we need to sell in a month, in a week, we need to sell $33,333 worth of vehicles. Make sense? So that's a way that, you could say, all right, how hard do I need to work this week, right? All right, let me bring up the notes to see. Okay. I've kind of done my own thing here today in terms of how I've approached this, not really gone off the packet. So let's take a look at this packet. And let's take a look at, I'm going to just bring up the homework assignment just to see if you feel like you could handle it. Okay. Could you do this? Sketch this using the intercept method? Replace x with 0, solve for y. Replace y with 0, solve for x. Yes? This one? It would suck fractions, but you could do it, right? Okay. This one? Pretty straightforward. Oh. Okay.
That would just be a straight line.
Yeah, so we haven't dealt with this, have we? So look at this right here, this equation. Is it a linear equation in two variables? No. It's a linear equation in one variable, right? So we said that there's only one answer. However, if I told you that this is a line, okay? If I'm telling you, okay? I'm telling you it's a line. I want you to draw the line. Then, can we solve that real quick? What's y? Y is, divide both sides by -5, you get -3, right? So, if I were to graph this, y is -3. It's right there, isn't it? Okay. Now, what is the ordered pair for that point right there? 0, -3. Yes? X is 0, y is -3. So does this point work in this equation? If I replace x with 0 and y with -3, is this still true? Mm-hmm. Yes, because there is no x in here, right? So all I need is that y is -3. Doesn't matter what the x is. So would this point have worked? What if I went over 2 and down 3? How about that point right there? -2, -3. Would that point also satisfy that equation? Replace x with -2. There is no x. Replace y with -3. Okay, it works. And couldn't I do that for any value of x? No matter which one? So that means all of these points that live on this line right here satisfy that equation. So when you have something like this, y equals some number, and no x is given, this is a horizontal line. Okay, so that's something we had not talked about, but I'm telling you now. If you ever get y is equal to a number, you're going to draw a horizontal line through that number. What if you have x is equal to a number? If you ever get x equal to a number, then that's going to be a vertical line. So growing up, I had some things that happened to me that I still remember to this day. And one of them is this thing with horizontal line. I could never remember which one was horizontal and vertical, like which is which. And then someone was like, no, horizontal, like horizon, right? The horizon. And I was like, oh yeah, okay, that's how I can remember it, right? Is that obvious to everyone? Okay, horizontal is this way, vertical is this way. There was another one. Have y'all ever seen this before? driving through a neighborhood. You ever seen one of those signs on the side of the road, you know, have little crossing, like people crossing or whatever? There's a sign that has like it's like a ship. It's like a ship going over this pointy hill. Have y'all ever seen that?
What?
No?
No.
So I remember being with my dad, and I was like, Dad, why is there a ship with a pointy hill? And he's like, he almost like leaned over and smacked the side of my head. He's like, that's a neighborhood watch, and that's like a criminal with their little hat hiding. Have you seen that one? That's what it is. But to me, it looked like a ship going over a pointy hill. And my dad just about kicked me out of the car. So anyway, certain things are like obvious, but sometimes they're not obvious. So this is horizon, horizontal. All right. Let's see what else in the homework. Make sure you can handle it. Okay, so you could graph that line. So on these, they just ask you to find the intercept, so you don't have to graph them. Here's where you start having a graph. So you could do that. That one, yes? 7? Yeah. 8? Ooh, what kind of line is that? Vertical line. X is a number. Okay, and then we go to our different method. Now for this one, I would say for this, I'm going to show you the method, but the homework is pretty much the same, so you could do it using the other method if you like the other method. Okay, and then there's some points, and then here's some word problems. So we'll get to those. So let's talk about the other method. You know what? Let's do something else. It's Monday. I think everyone's tired. Let's do it. Let's do a short in-class quiz, and I'm going to allow you to work first. Let's see. We stop class at 10:45. So the first 10 minutes, I want you working by yourself. You can use your notes. You can use anything you have in front of you. Okay. Then after about 10 minutes, you can talk together. All right. Good. And it's going to be over what we just did. So why don't we just kind of knock out some of the homework right now? How about you do... So on these 6 problems, this will be turned in. Okay, you're going to turn these in. So do this on a separate sheet of paper. Make sure you put your name on it. I want you to, for all 6 of these, I want you to graph them.
What page is this?
I don't know the page. Let me see. I'm going to tell you what I think it is. 35. Hopefully that's the same as what you have.
Yep.
Okay. So even though the instructions say just find the x and y intercept, I want the full graphs for these. All right? So 10 minutes starting now. Then after that, you'll have about another 10 minutes to talk to one another. If you have a question while you're doing this, want me to check something, go ahead. If you finish, turn it in. You can go. Any questions on what you're doing? All right. And we'll do the other method, we'll do it next class.